All right, so right here, this tells us we have a function, and there's two pieces to the function. After the comma is what's called a domain restriction. So this first piece is 2x plus 3, and then we have a domain restriction. And the domain restriction says that I'm only allowed to plot points where x is less than or equal to 1. When you look at 2x plus 3, could you tell me what picture that makes on the graph, 2x plus 3? Let me rephrase that. Please tell me what picture that makes. A line, right, it makes a line. But we're not going to graph the whole line. We're only graphing x values that are less than or equal to 1. And then we look at this one right here, negative x plus 4, comma, x is greater than 1. This, again, is a domain restriction. So we will be graphing negative x plus 4, but we can only use x's that are greater than 1. Greater than 1. So as I look at these two pieces, what's kind of that division between the two pieces? What is splitting up these pieces? What number? 1. When x equals 1, that's kind of the division between the two pieces. So what I like to do is come over to my graph, and at x equals 1, I'm just going to draw a dashed pencil line so that I know that one piece is going to be on the left side and one piece is going to be on the right side. And when I look at my pieces, they're always in order. So the one that's going to be on the left is the top one, the one that says less than or equal to 1. That's going to be the left side. And then my green one will be on the right side. I'm not going to graph them on both sides. Now there are different ways that you can graph. I'm going to show you different possibilities. One way that you could graph would be just using, like, if it's a line, slope and y-intercept. So for this blue one, the slope is 2, the y-intercept is 0, 3. So I will begin at 0, 3. This is where I'm going to use my pencil and then later color it in pen when I'm happy that I did it right. 0, 3, I'm going to put a point, and then up to over 1. But then I hit this border line. And according to this domain restriction, I cannot take the blue one to the right side. So I can only go to the left with the blue. So instead of going further, I'm just going to go down to left, and finish my graph that way. And it is a line, so at this point I'm going to use a straight edge. And I'm only graphing it in the section that it should be in. To show that that is the end of the line, that right on x equals 1 is the end of the line, I'm going to put a dot. So now everybody can see that is the end of my line. That's where my line stops. Just like you did in geometry, endpoint. Now we're going to graph the green one. And this one, again, is y equals mx plus c, so I'll do slope. It's negative 1, and my y-intercept is 0, 4. I'm going to use my pencil, just in case I make a mistake first. 0, 4, and then negative 1 over 1, negative 1 over 1, negative 1 over 1. Okay, but if I connect all these points just like I graphed them, I'm going to have a problem. Am I allowed to graph the ordered pair 0, 4 if I have a restriction that says x has to be greater than 1? I cannot graph that one. Can I graph, there's another point I have on here, can I graph the point 1, 3 if x has to be greater than 1? Can I graph the point 1.00000000001, comma, I don't know, negative that plus 4. I can graph that x. I just can't graph the x that's 1. So what I'm going to do with this line is I'm going to put I'm going to erase the point that I don't need. And I'm going to put an open dot at 1 because it's going to go all the way up to 1, but it can't equal 1. And then I will graph my line on the right side of that division. So that is the piecewise function example A. It is a function. If I took a straight edge and I went from left to right, there would be no place where both graphs hit vertically at the same time. Because what happens at 1? One is open, one is closed, so they don't hit at the same time because one's open. Okay? Next one. So question B, I'll graph these a different way so you can see other methods of graphing. Question B, x squared minus 4, my domain restriction is at x is less than 2. And then square root of x minus 1, domain restriction is at x is greater than or equal to 2. If I have a less than, is that going to be an open or a closed dot? That'll be open. It's open if it's not equal to. So if I have this bottom one that says greater than or equal to, that's going to be what kind of dot? Closed. And then I'm going to go over to my graph, and at x equals 2, I'm going to put a vertical line that's dividing up the two pieces of the graph. My blue one's going to be on the left side. My green one's going to be on the right. All right, x squared minus 4. I will do this one with a table. Oops, I just put that in the wrong column, though. Nope, that didn't work. The white out in my finger. Awesome. All right. Anyway, so the x's that I can choose are x's that are less than 2. So maybe I choose -3, -2, -1, 0, 1. Should I choose 2? I actually should. But remember, this guy is going to be open. But I do want to go all the way up to 2 because I'm not going to put 1.999999 in my table. So if I'm making a table, I can just plug these numbers into x squared minus 4. That'll be 9 minus 4, so 5. That'll be 4 minus 4, 0. 1 minus 4, -3. Then -4, -3, 0. So I have some points. -3, 5, -2, 0, -1, -3, -4, 0, 1, -3, and at 2, 0, that one's going to be open. And once I've done a good job and I didn't make any mistakes, now I'm going to get my pen. You totally do not have to use color in your homework. You just want to use pencil the whole time. Some people just have trouble getting these, and I feel like using the color helps you separate the two